We live in a decimal world, 0 to 9, but computers, they live in a binary world, just zeros and ones. Today, I'm building a bridge between the two. This is the binary translator. It takes a standard number and instantly converts it into 8-bit machine code. To build it, I'll be using an Arduino, a Shift Register, and a very tricky display that I got from my old MP3 player. Here's the first challenge. This isn't a normal display. It controls 4 digits, that's 28 LED segments, using only 7 pins. It uses a technique called Charlieplexing by rapidly switching pins between input, output high and output low. We can target specific LEDs without lighting up the whole board. First, I'm going to wire the display directly to the Arduino using 220 ohms resistor. The wiring has to be precise because every pin acts as both an anode and a cathode at different times. Next, the binary output. I didn't want to use up 8 more pins on the Arduino for those LEDs, so I'm using the 74HC595 Shift Register. It's a series to parallel converter. It lets you control all 8 binary bits using just 3 wires from the Arduino: data, latch, and clock. To control the device, I'm adding 2 buttons, one for up and one for down. I'm using the Arduino internal pull-up resistor to keep the wiring clean and simple. The code is where the magic happens. It does 2 things at once. First, it constantly references the display hundreds of times a second, so your eye sees a solid number. Second, whenever I press a button, it calculates the new value and shoots the binary data over the shift register instantly. Let's test it. I'll dial in the number 5. On the right, we see the decimal 5. On the left, looking at the binary LEDs, we have 4 plus 1. This project is a great way to visualize how data is stored inside the CPU register. Thanks for watching. Do well to subscribe, like, share, and keep building.